The first thing I did in this problem was set up a coordinate axis where the y is pointing up and the x is pointing to the right. And I started with Coulomb's law, which is kq1 times q2 over s squared. So in this problem, you have the force exerted on the dipole by Q, which is in two parts. You have Q on the negative part of the dipole, which would be r minus delta S over 2 squared. It's halfway through S is where R is. So then you have to subtract the small part because that's where the negative dipole is. You have to subtract half of S because that's where the negative dipole is. And then you have FQ on the positive Q, which would be R plus delta S squared. So to get F net, you subtract the two halves. So you can pull the KQ out front and just have this part left. So then to combine the denominators, you have to multiply by the same thing on each side. And then you FOIL this and simplify, and you get negative 2r delta S in the numerator. To simplify the denominator, you can pull out an r squared value. It has to be r squared because even though it's just r here, it's still inside the parentheses of this. So you pull out an r squared, and that becomes 1 plus delta S over 2r. And then 1 plus negative delta S over 2r. And this is when you can use your binomial approximation. And then that gives you r to the fourth because you combined both r squareds. And you get 1 minus 2 delta S over 2r and 1 plus 2 delta S over 2r. And that's plus because this negative and that negative cancel out to make a positive. And you can simplify these to just be 0 because you know that S is much less than 1. So that's like it's a 0 here. So those would just cancel out and become 1. So you just have r to the fourth in the denominator. Then you can cancel out an r on top and an r on the bottom. And that gives you F net equals negative 2 KQQ over r to the third. And it's negative doesn't really matter because the dipole is facing so that the positive is further away than the negative is. So this charge Q is going to be pulled towards the dipole, which if you look at the coordinate plane, you know that it's going to the left, which would make it negative.